We're here at Jono Valley at Race to the Sky 2015 with Jono Climo. Jono's been a good friend of mine for a number of years, and in fact back in the early days when I first built my Mitsubishi Evo drag car, Jono was the guy that I entrusted for all of the fabrication work. He's, in my opinion, probably one of the premier fabricators in New Zealand, and I'm not even joking there. His work is top notch. Since those years ago when he helped me build that car, he's now formed a company called Jono's Racecraft, and obviously, Jono, your passion is off-road four-wheel drives, and we're here to talk about your truck that's over to the side of us. It's a Class 8 Thunder truck built for off-road racing, and obviously it's a little bit out of its normal league here, normal duties in a Race to the Sky hill climb. Let's start at the start though, Jono. You built this truck from scratch, so it's not based on a production truck, is it?
No, it's I've looked around and done some research, and for New Zealand conditions I've kind of gone along the lines of a hybrid between an American trophy truck and a Pro 4 truck. Pro 4 truck is a stadium based truck. They're usually quite a low ride height. They're quite powerful. And the trophy trucks, the Pro 4s are four-wheel drive, trophy trucks are two-wheel drive. They're a lot taller, they're a lot bigger, and they can handle the bumps a lot better in the desert racing. They're a little bit cumbersome on a stadium course. For New Zealand conditions, we kind of thought, well, it's not really suited to a trophy truck or a Pro 4, so we kind of tried to build something halfway in between.
Yeah, what was your sort of design process? Obviously, you assessed both of those types of truck and decided you wanted something in between. So then you've got a clean sheet of paper to start building from. How do you turn a clean sheet of paper into a competitive four-wheel drive truck? Actually, I'll start that again. Are you using any sort of technology like SolidWorks, 3D modelling or anything like that, or are you using pen, paper and your imagination?
Believe it or not, I'm completely computer illiterate, so everything you see in this truck has come out of my head. There are no designs for it whatsoever, bar a few drawings that I did for the laser cutting items. They were usually done on cardboard and done to full scale. Things like the transfer case, which we'll get into later on. Also another design of mine that I've drawn. Again, I don't use computers that often. Hopeless in that side of things, but as you see it now, without a word of a lie, it's all designed out of my head and built from 6 months of thinking about things.
Now, looking back, now that you've had the truck out there, it's competitive, you're racing it, and looking back at that design process, is there anything you think you've overlooked or anything you would have changed?
There's always weight factor. Like the lighter you can make something, the less you have to shock it, less if you have to spring it. There's less, obviously power to weight ratio is increased. So getting more weight out of it would be a great start. But we built it. With off-road racing, it's a bit of a compromise. You've got to try and make it as light as you can, but you've also got to make it strong. They take a hell of a lot of beating. The drivetrain, a gearbox in a street car that can handle 500-600 horsepower, they usually say for off-road racing halve it because of the shock loadings. There's immense shock loadings.
In terms of that and getting that reliability, particularly into the chassis components, the pickups for your suspension, your diff, etc., or diffs, the design for that, how strong you needed to make it, what size rose joints you wanted to use, was there any analysis, or formal analysis on that, or is it again just from experience?
A little bit of experience, a little bit of guesswork. I don't like using heavy plate. So you can, in general engineering terms, anything in double shear and everything on the truck is in double shear. You can reduce your sizes of plates and stuff like that. You carry the shock loading over that. Again, you start adding bigger plates to carry, thicker plates. You start increasing weight of things. And the more you increase the weight, the stronger you have to. It's like a increasing circle. So what we've done was a bit of guesswork, a little bit of knowledge and past experience. And so far, we've had no failures on componentry like any of the engineering, the arms or anything like that I've done frame or anything like that. We've had a 2 years of sorting out bugs in the system. We've found the weak spots, and we've got it to a stage now where it's starting to become very, very reliable. Cross fingers. And we've got a few other things we want to do to make it even better. Like we're going to do a rear diff, bigger diff, bigger axles. We broke, for example, we had a race where we broke one axle, a half shaft in the front end from contact with another vehicle. Now that's the first time we actually shared one. We carried on with the race in 3-wheel drive. The power now got transmitted through 3 wheels. We broke the other front half shaft, and the brakes were very different. One was it's very interesting when you break something to do the analysis on it. So we broke the other side, and then we went into 2-wheel drive, and then we broke the rear axle. So you might have a combination of parts that work very well when they're all working together. As soon as you break one link of the chain, everything starts failing around it.
It sounds like if that was the case, you must have been very close to the fatigue or strength limit of those components anyway. Now, you mentioned power to weight ratio, and I'm interested in the power that it's making. Can you talk us through the power plant, the engine in the truck?
Okay, yeah, I'm a bit of a Toyota person, so I've had Toyota V8s over the years, as you know. We've had a few supercharged ones, one that you've tuned. And when building this truck, it had to be a Toyota V8. I would have loved to get my hands on the 5.7, but they were a bit sort of rare at that stage. So we went back to the 4 litre. 4.3s, they say the bores are a little bit close, and they tend to split the blocks between the bores. So we went back to the 4 litre.
So we're talking the 1U and 3U ZFE series there.
Yeah, that's the one, 1UZ and the 3UZ. We went back to the 1UZ, which is the 4 litre, the variable valve timing. The heads are far superior to the original motor. Unfortunately, the internals are weak, so there's a combination of CP pistons. We went to Eagle rods because they were deemed well strong enough for an 8-cylinder engine with turbos. The cams and the heads, Gary Croker did the heads. He bought it and it's got bigger, oversized Manly valves, slightly bigger. And Henry from Auckland Cams, he's a very, very intelligent guy. He sat down and says, right, we're going to do this motor, we're going to do the cams. He said, what's the weight of the vehicle, what gearbox are you running, where do you want your power band? He went through the whole lot of stuff and then designed a cam around the whole package. And it is a heavy truck and it is a small motor, but the power it makes and where it makes it is very well suited to the whole truck.
So talking about that power band, let's see, what are you running in the way of boost, what fuel are you running, and how much power is it producing?
Fuel, we wanted to run a normal fuel. It's just readily available. With off-road racing, it's really more about durability and finishing races, especially endurance racing, which the truck was based for. So we were stuck with 98, BP 98. We have had a couple of incarnations of this engine, and at the moment we're running 9-to-1 compression ratio, and with the cams, we're 10 pounds boost. And at that boost level we're 668 horsepower.
That's flywheel or at the wheels?
Yeah, no, that's flywheel. And 14 pounds boost, it jumps up to 773. We were going to run 18 pounds, which is the limit for those turbos. The turbos are Steve Murch special. They are a Subaru split pulse exhaust housing, all in trying to get the turbos to come on earlier and give us a broader power band. He has done TDO5 cores with TDO6 front covers, and he's got his own billet compressor wheels in there. I think they are a big 16G. Everyone sort of says, oh, the turbos are too small. We're making plenty of power, a beautiful power band to use, and it goes like hell. I think it's, as far as my memory goes, I think it's 674 pounds tall.
You mentioned a little bit earlier just about the power band and getting the power to be usable. So what sort of RPM are you seeing full boost or a decent usable power band from?
We've got a solid power band from 2,000 to 7.5.
Now that's got to make the truck a lot easier to drive.
Yeah, it does. when you're dealing with a bigger vehicle like this, you're running 35-inch tyres. To give you an idea, they're 48 kilos for a wheel and tyre. So you've got basically close to 200 kgs of wheel and tyre and inertia in those. So you do need something. The truck itself, when it's in endurance mode, it carries a extra fuel tank, another spare wheel, and driver, co-driver, and all the fuel. And we're looking at around 1950 kilo. So it is a heavy little truck. But when you look at the wheel combos, 250 kilos of that is a wheel and tyre. There will be about 150 litres of fuel on board, and driver and co-driver. On a good day, I'm sort of 83 odd kilo, and I chose a really good co-driver. He's lighter than me, so. But yeah, when you start looking at weight of vehicle and then your gearing and stuff like that, you sort of look more for a big usable torque band, and then with the truck we've also designed and made our own transfer case. Again, drawn it up on paper, and I've got a friend of mine who's done all the CNC work, CMS, and that works extremely well. But we've also got gears in it, so we can change the ratios through the transfer case.
Is that the reason why you designed your own rather than using something production based or off the shelf?
No, I had to reverse the drive around. A lot of guys will use a standard four-wheel drive gearbox and transfer case, and they'll swap the diffs upside down so that the rotation of the drive shafts work. I'm using a Geartrag. It's a Toyota Geartrag 6-speed box that comes out in the JZA 80 Supras, which are very, very bulletproof. They're a very strong gearbox. So I'm using a two-wheel drive gearbox with a short shaft, goes into the transfer case, reverses the drive around the correct way, and then splits it off to the right direction. So it's got a two-purpose, changing the drive the right way. The diffs are up the right way. The drive shafts are all running the right way. So and the bonus is that we can change the gears, and we've been playing around with 3 sets, and between 1.2 and 1.6. Ratio change, and we've settled in the middle with 1.4, which is a good balance for everything that we do.
We were talking earlier before we started rolling the camera about the drivetrain setup, and that centre diff is locked. Do you find that that's a disadvantage compared to using a more conventional limited slip or open differential in the centre?
It changes characteristics of the thing. The truck is very it's very solidly footed. It's 2150 wide across the wheels, so very, very wide, and it's got a very long wheelbase. It's about 3.1 metres wheelbase, so it's got a very, very big footprint. The lock drivetrain uses custom LSD diffs, which have been put together by Cane Barry Motorsport, and it does suffer from trying to get around tight things. It has a few characteristics that are unusual with the truck, but make it quite nice to drive, as long as you can get your head around it. We are playing with a centre diff at the moment, which is basically a clutch pack centre diff, where I can pull a handle, it'll disconnect that drive to the rear drive shaft. I can still drive with the front wheels, to effectively turn it into a front wheel drive car, and a more pull on the handle will lock the rear brakes. So it gives me the ability to flick the thing around in the tightest spots. That's about its real bad Achilles heel, is the fact that it's a big truck to get around tight spots.
Yeah, I can't imagine it being a lot of fun on anything that's really tight. Just want to talk a little bit about the engine management system. So can you tell us what you've got in there actually managing that engine?
Yes, it's proud to say it's a Link G4 Extreme. It's been a great computer. We've got the dash on board as well, and that saved me from a few scenarios where we were getting hot. It's been a great system. It hasn't let me down. Yeah.
Is there anything with that, with the type of racing you're doing? Are you relying on data logging, or is it really just forget about the engine and just concentrate on driving the truck?
Well, considering I'm computer illiterate, we haven't gone too much into the data logging. I'm kind of lucky. I'm a mechanic by trade, so I've got a little bit of mechanical knowledge. For example, this morning we ran up the hill. The last round that we did, we're overheating on a short course. So I've just changed whole radiators around. We never really got to test it before we came down. We had a scenario where it was missing up the hill because the temperatures were too low. So now we've got excess radiators, which is better than having not enough. But now we're playing around with blocking a percentage of the radiator to keep those temps in the right zone. And the second run up the hill wasn't missing, and I think we've cleaned 40 seconds off our first run up the hill. First run, we were taking it easy and learning the grip levels and that sort of thing. So no, pretty happy. But we're constantly, anything that we do to the truck, we're always trying to improve. And so far, so good. We haven't done anything where has put it backwards. Everything we've done has made it better and better and better. And as long as we continue to do that, it should end up being quite a good truck.
As long as all your changes are always moving in the right direction, that's got to be positive. Look, Jono, it's an amazing looking truck. It's a real credit to your fabrication skills and your imagination to come up with that without using computer modelling or anything. So thanks for giving us a bit more insight into that, and we wish you the best of luck for the rest of the weekend.
Thanks very much. Yeah, we'll see how it goes. As long as I'm having fun, that's the main thing.
Cheers.